So today what we're going to do is we're going to talk about equations. Specifically, we're going to talk about one-step equations and how to solve them. But the first thing you need to know is, what is an equation? So an equation is a mathematical statement that two things are equal. So it basically has an equal sign. And that's really all an equation is. Now you have inequalities and you have expressions, but inequality says less than, greater than, less than or equal to, greater than or equal to, and expressions don't have an equal sign. So equations, and they just have an equal sign in there. That's what an equation is. It's just this side is equal to this side, and that's what an equation is. So if we know what an equation is, a lot of times what you'll see are algebraic equations. So they have variables in them. Now, a lot of times they'll set these up and they'll say, well, how much is that variable worth? I want to know what x is. Now, again, this variable can be all kinds of different things. But when you have this side set equal to this side, what they're saying is that, hey, everything over here has the same value as everything over here. And what they'll come in and they'll go, well, if that's true, how much is that variable worth? And they'll ask you to solve for that variable. So what we're doing is we're going to solve for our variable. Now, most of us can look at this and go, oh, well, 3 plus 2 is 5. And you should be able to do that. But I want you to be able to actually prove it. So in order to prove it, you have to line it up and show exactly how this works. So what we're going to do is we're going to draw a line right off this equal signs. And we're going to show it how everything works here. We're going to prove that this is true. Okay, that's what we're doing. We're solving for x. And by solving for x, we're saying we're going to get this variable all by itself over on this one side so that we know its value. Okay, so in order to do that, we have x plus 2 equals 5. Well, we're going to do the opposite of plus 2. Well, the opposite of this would be minus 2. The other way you could do this is to add its inverse, add its opposite. Well, plus 2, I could add minus 2 or negative 2 to it. So here we go, we have that. All right, what you do to one side, you have to turn around and do to the other side here. So whatever you do over here, you have to turn around and do to this other side. Otherwise, you don't keep that balance on your equation. If you just do something to one side, it becomes imbalance. So now they're not equal anymore. So we got to keep them equal. We got to keep them the same. Okay? So what I do to one side, I got to do to the other. So x plus 2, and I added negative 2 here. I mean, we could have also just done this, minus 2, because those two things are the same thing. And you have to remember that. Now, I'm doing it plus negative 2 on purpose because later on some of these other ones, it'll look a little cleaner. Okay, but either way, whatever you see, that's the way you do it. Okay, so plus a positive 2, plus a negative 2, because that takes this and puts it at 0. It gets rid of this, what I'm trying to get rid of, because I want to get this all by itself. And that's the theme as we move through this, is getting this all by itself on one side. All right, so whenever I do this, these two cancel out, and all I have left on this side is this x, which is exactly what we're trying to do, get the x all by itself. X equals, well, what's 5 plus a negative 2? Well, remember your sign rules, right? You're adding a positive and a negative, so you subtract, keep the sign of the bigger number. So 5 minus 2 gives me 3. The 5 is bigger than the negative 2, so it's a positive 3. So x equals 3. Now, that's exactly what we said right at the very beginning. Oh, if I look at that, I know that 3 goes here because 3 plus 2 is 5. If I take that and I plug it back into this original one, I can check to see if it's true. So x plus 2 equals 5, so x must equal 3. Has to. This is the proving of it, though. This is what you've got to get good at. Because anybody can look and go x plus 2 equals 5, so x has to be 3. But being able to show these steps and show how this works is what you have to get good at, because this is the proof that that's a true statement. Okay? This is what I'm going to be looking for. You have to be able to do this. Okay? Because what's going to happen is these problems are going to go from being small to really big, and they're going to have multiple steps in it, And in order to be able to get through this, you're gonna have to do all of these. You have to take it a step at a time. This is the beginning for that. Be able to do this. All right, so here we have the x on this side. Over here, now we have the x on the other side of the equal sign. And instead of adding 2 here, now we're subtracting 2. It doesn't really change anything. We still want to get the x all by itself. It doesn't matter if it's on this side or if it's on this side. Nothing's changed. So now, do the same thing. I draw the line just to keep me honest. Make sure that I do what I do on one side, I do on the other. Okay? Well, x minus 2, okay? X minus 2, this goes with this, click, click, is adding a negative 2. Well, how I get rid of that? Add a positive 2. Same thing. It's the opposite of it. I'm adding the opposite of it to get rid of it. But if I add 2 here, I have to add 2 over here. All right? Well, these cancel out. I bring down what I have left over. Whatever's left over here comes down. X equals, and now I've got to add these 2 together. 5 and 2, 7. And if I want to check it, I take this and I plug it back into my original problem. 7 minus 2 is 5. I have a good answer there. And this is what I'm looking for. Showing the steps, showing how everything works. Because again, later on, the better we get at this, at the 1 steps, the easier the other steps are to go through. All right, so here, x plus negative 2 equals 5. Wait a minute, x plus negative 2. Isn't that what I just did up here? X plus negative 2. It's the same thing, same problem. The difference was this x minus 2, and I did click, click. Here, that's already done. But I'm showing you all the different ways that you're going to see these problems, right? So same thing. And again, look, on that one it was over here. On this one it's over here. But it doesn't change anything. Plus 2, plus 2. I drew my line down the center. 5 plus 2 is 7. These 2 cross out, right? Because that's the whole point, is to get rid of that. So I get my variable all by itself. X equals 7. Again, same thing, worked out, perfect. Now here, same thing, find my variable, I want to solve for the x. Again, this variable could be anything, it doesn't matter, but we have x in here. We have 2 plus x. Well, there's no sign in front of that, that must mean it's a positive 2, right? Well, how do I get rid of a positive 2? Well, I can add a negative 2, or I can just subtract 2. They're the same thing. I'm going to add negative 2. Add negative 2 here. What I do to one side, I have to do to the other. Okay? These cancel out, and what I'm left with is x equals 5 plus negative 2, gets me 3. This problem was essentially the same thing as this one. They just switched those numbers around. That's all there is to it, guys. If you can do this, you're going to be good. All right. We're just going to keep moving on, but these are the different ways that you're going to see all these problems. Take a look at 5. I got negative 2 plus x equals 5. Now, a lot of times I get this question, oh, is that minus 2 or is that negative 2? Same thing. It's the same thing. Negative 2, minus 2, but it doesn't matter because that sign right there goes with this number. All right, so again, draw my line. Now, how do I get rid of negative 2, I add its opposite, its inverse, add. Oh, what's the opposite of negative 2? Positive 2. And this works because of the way the number line is, right? Okay, if I'm at negative 2 and I add 2 to it, I get back to 0, that cancels that out. That's the whole point, right? Add 2 here, add 2 here, okay? These 2 cancel out. All I got left over here is this positive x, because this goes with this, okay, positive x, so x equals, well, 5 plus 2 is 7. This problem, basically the same thing as those two. Okay, now over here, take a look. This is the other type of way that they're going to do this. 5 equals x minus negative 2. Well, sign rules. Most things come back to being able to deal with those sign rules. Click, click. So I have x plus positive 2. Okay. How do I get rid of a positive 2? I add a negative 2. add a -2. And these cancel out, okay? Bring down the x, 5 plus -2, 3. Subtract, keep the sign of the bigger number, and there you have it. Guys, you can do this, watch your sign rules, sign rules, sign rules, sign rules. You can do your sign rules, you'll be fine. All right, that was addition and subtraction. Now we're gonna look at multiplication and division. Now over here, I said, basically, you need to cancel it out. Well, it's the same thing over here. You're trying to cancel it out and get that variable all by itself. That's all you're trying to do. So again, we're gonna draw a line, but now, here what we have is that 2 right up against the variable, that operation is multiplication. Well, how do you undo multiplication? Well, you do division. Okay, so we're gonna actually divide by 2 over here. But what I do to one side, I do to the other. Okay, so divide by 2. Now, what happens here is when I divide by 2 is these two things cancel out, they become 1s. And then you're going to multiply that 1 times x, and that just leaves you with x, because anything you multiply times 1 gets back that same value. That's the identity property. Okay, so these two cancel out. But what I do over here, I must do over here. Now notice, I didn't change the sign of this. When I was doing addition and subtraction, I changed the sign. That was the whole way that you get rid of that, because that's the way that addition and subtraction work. But over here, I'm not changing the sign here. 2, this is a +2, so I divide by a +2. This was a -2, I would have divided by a -2. That's just the way this works, because of division. Okay, so these two cancel out. And it leaves me with just the x. So x equals, okay, and then I got 8 divided by 2, which is 4. And that's all there is to this. You're just trying to do the opposite operation over here in order to get rid of it. All right, down here, -2x equals 8. Again, like I just said, now that it's a -2, a lot of you guys are going, oh, well, isn't that -2? No, that's -2 times x is what that is. Okay, that's -2 times x. The common mistake here is to try and do addition here, plus a +2 and get rid of it. Don't do that. This is -2 times x. The operation is right here. So we want to divide by -2 and get rid of that. Okay? But what I do to one side, do to the other, these cancel out. Now notice again, I used -2 because this was a -2. Right? That gets rid of that. Leaves me with an x. Now I have 8 divided by -2. Well, a positive divided by a negative gets me a -4. Okay? Make sure you see how that works. Negative divided by negative gets me a positive. Positive divided by negative gets me a negative. Watch that. That's a common mistake right there too. A lot of you put that as a +4, but that's not what that is. That's a -4. All right. Now, it doesn't change anything if it's on one side or the other. Now, notice all these numbers are the same. I did that on purpose so that you get to see this same problem presented to you multiple different ways. Okay, a equals -2x. My variable's here. I want to get it all by itself. Just because it's on the other side of the equal sign doesn't mean anything. I still want it by itself. So, -2x times x, -2 times x. Opposite operation is division, so I'm going to divide. Divide by -2. Divide by -2 over here. I divide by -2 over here. There's my line. Okay. These two, again, cancel out. This is the same problem as this one. It's just switched. Gets me x equals 8 divided by -2, -4. Okay. That's all there is to that. Again, all we're doing is proving how this works. We're showing how it works out. We're solving. We're writing our steps down so that you can see exactly what's going on. You've got to get good at this because the problems get bigger. All right. -8 equals -2x. Okay. Draw our line. Divide by -2 because this is multiplication. So the opposite of it is division. What I do over here, I do over here. But now I have this negative 8 divided by negative 2. All right, well, these cancel out and leave just the x. And again, right over here, negative 8 divided by negative 2. A negative divided by a negative gets me a positive, and 8 divided by 2 gets me a 4. Watch your sign rules. Most of the mistakes steering this are sign rules. Pay attention to them. All right, so that's multiplication. That's really all there is to multiplication. So now we got to move into division. All right, well, 8 equals x over 2. Well, what's the opposite of division? Well, it's multiplication. Okay, so x divided by 2. So if we want to get this x all by itself, we got to do the opposite operation. The opposite operation of division is multiplication. So we're going to multiply by 2 over here. But if I multiply by 2 over here, I have to do it over here too. Okay, draw my line. Now, what happens here is really this. Okay, you got 2 over 1 times x over 2, and these two things cancels out and give you 1. Okay, so now you have x times 1, which is x, over 1. Well, any number over 1 is that number. So now you got x left over here. Okay, that's really the math that's going on over here. Okay, the way I normally show it though is just this, because I know that that's what that happens. Okay, I know that that's how that happens. Okay, so now I have x. Well, what's 2 times 8? 16. And guys, this is a little bit easier setup once you get accustomed to, oh, this is division, so I got to use multiplication. Well, once you get used to that, it's not that big a deal. All right, same problem, reversed, and now I've got a negative here. Okay, so x over negative 2, opposite operation. So this is division, so I'm going to use multiplication. But now here, what am I going to multiply by? Well, since this is a negative 2, I'm going to multiply by negative 2. Whatever that bottom number is, that's what I'm going to multiply by. Okay? Same thing to the other side. Have my line to keep me honest, make sure I did both sides. Okay? These cancel out. Bring that down. X equals, now I have a positive times a negative gets me a negative 16. Right? That's all that's going on there. Okay? Whatever this bottom number is, that's what I multiplied by to clear that out, to get rid of it. All right? There's that. Same thing up here. X over negative 2 equals negative 8. Here's my variable. It's being divided. I want to use the opposite operation, so division, opposite of it is multiplication. Multiply. I'm going to multiply by whatever's on the bottom, negative 2. So negative 2, multiply by negative 2 over there. I multiply by negative 2 over here. Okay. These cancel out. Give me x equals, and now I've got a negative times a negative gets me a positive. So now I've got a positive 16. All right. That's division. That's multiplication. Addition, subtraction. I got one last one here just to show you, because you're going to see this one a lot going forward. They like to throw this in to try and trick you. All right. So here we're going to draw our line. Now, I have a negative x equals negative 35. There's two ways to look at this. There's the one way where you say, well, they want the opposite of x equals negative 30, or the opposite of x equals negative 35. Well, if you got the opposite of x equals negative 35, an actual x would be a positive 35. I'm going to show you exactly how that works. Okay? What's always in front of an x if there's no number there? There's always a 1. So you have a negative 1x equals negative 35. Well, negative 1 times x, that's what you have. Okay, what's the opposite of that? Well, you can, there's two different ways to do this. You can divide by a negative 1, which cancels this out, and divides by negative 1 over here. That cancels out your negatives, gives you x equals, oh, negative divided by negative gets you 35. There's that way. Okay? That way works. And is probably the best way to do that right now. I don't know if I should show you this other way. All right, so you also have this. Okay. Again, -1, right? You can multiply both sides times -1, and it's gonna do the same thing. -1 times -x, and I'm gonna put that in parentheses so you see that that goes together too. That gets you a 1x equals -35 times -1, gets you 35. Guys, stick with this one. Don't do this one yet, do this one. This one will make more sense later. Stick with that one, that's the one that you're gonna see. But this does work too, and if you see them, it's okay. But stick with this until you get really good with your sign rules and how everything works. This works, and if you see it, it's fine. But you'll understand this because it sets up nice and pretty for you, just like you've been doing everything else. Yeah, guys, that's really all there is to solving a one-step equation. Remember, do the opposite operation with it and watch your sign rules and you'll be fine. Remember, what you're trying to do is get rid of that other part to get the variable all by itself. And what you gotta do to one side, you do to the other. All right, if you have any questions, let me know. Here for you.